Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. So in this video I would like to discuss the Sidesway frame. And I want to focus on actually under step number 3, step number 3A, how we are going to assume FEM, and then how from the FEM that we have assumed, how we are going to calculate FEM for remaining members related to the first FEM value that we have assumed. Okay, but before that I want to highlight important things actually about frame with Sidesway. Frame with Sidesway, especially when we have one inclined column. Okay, so let's say if we have this. So I want to focus direct on step 3A. Okay, 3A. So 3A is Sidesway frame analysis. So step 3A like this. Okay, for example, if we have this frame, okay, if we have this frame, so we have to identify, as I mentioned in my previous video, in frame with one inclined column, we have to have one triangular. Okay, the relation between delta 1 prime, delta 2 prime, and delta 3 prime, and we have to identify that one in the frame. Okay, so let's say this is the frame. Okay, let's say this is the frame. Okay, can you listen? Okay, since delta must be perpendicular to member, so we will have this triangular. If we have this frame, we will have this triangular. We have this triangular and this. Okay, so okay, perpendicular with column AB. Perpendicular with column AB is this incline. Okay, delta 1 prime. Perpendicular with column CD is horizontal. This is 3. And perpendicular with beam is vertical displacement. This is 2. So where is this triangular? Okay, where is this? Okay, in this frame. So it is actually located at this. Okay. Okay, so actually this is the position. Okay, the position of this triangular in the frame. Okay, in the frame. So what we need to do is we will have, okay, since we know that delta 1 is for member AB, okay, delta 2 is for member BC, delta 3 is for member CD. Okay, so we will have AB, BC, CD. AB, BC, and CD. So we have to choose one member to assume the value. to assume the value. So normally we choose AB. And actually, if you want to assume 100 for CD also can. Okay, so let's say we assume 100. Okay, 100 at AB. This is 100 that we assume. Okay, then we have to look at the behavior. It rotate clockwise because the frame is tend to sway to right direction. It rotate clockwise. Okay, the angle is positive, so FEM must be negative. FEM must be negative. So that is why we need to put negative to represent the right behavior. Okay, the right behavior. So we have to calculate this value and this value. Okay. So what we need to do now is we have to apply formula to calculate FEM. Okay, FEM is 6EI. The formula 6EI for AB is delta 1 divided by L LAB. This is LAB. Okay, and then 6EI delta 2 prime over LBC, squared. LBC squared. And then, okay, and then 6EI delta 3 over LCD squared. Okay, so let's say LAB equal to 7.5 meter, and then LBC equal to 5 meter, and LCD equal to 9 meter. Okay, so it is 7.5. So we have to put the L value. So we get okay, I just need change to 7.5 square. Okay, this is 5 square, and then this is 9 square. Okay, now we want to identify delta 2 in terms of delta 1, and delta 3 in terms of delta 1. So we have to actually identify the angle. Okay, we need to identify the angle. We need to identify this angle. Okay, the angle. Okay, the angle basically when angle is given normally angle is given at this position. Okay, let's say this is 65 degree. Okay, so this 65 degree, we have to refer back to mathematical concept about angle. So this is 65 degree. It means that if this is 90 degree perpendicular, so what is this value? Okay, doesn't matter because actually this is 65. If you want to use that one, okay, or we can also use 90 minus 65. 90 minus 60 is 30, 25. So this is 25. So doesn't matter which angle that you want to use. Okay, let's say I want to use 25. This 25. Okay, I want to use this 25. So I want to have delta 2 in terms of delta 1, delta 3 in terms of delta 1. So for delta 2 in terms of delta 1, I get delta 2 prime equal to, we got sine. We use sine, this is sine 25. Delta 1 prime. And then we have delta 3 prime equal to, it is cos, because we used 25 angle degree. Okay, this is cos 25 delta 1 prime. So this we substitute into the table just now. Okay, so what we get is, what we get as is 6 EI delta 1 prime, this is sine 25 over 5 squared. And for delta 3 prime, it is 6 EI delta 1 prime, this is cos 25. So this is 9 squared. Okay, so we calculate the value. It is in terms of EI delta, okay, so this one in terms of EI delta 1. So in terms of EI delta 1 prime. Okay, I want to calculate the ratio. I want to calculate the ratio. So it is 6 divided by 7.5 square. It is 0.107. Okay, and then 6 times sine 25. Okay, 6 times sine 25 divide by 25. It is 0.101. Okay, and then 6 times cos 25 divide by 9 square. So we get 0.067. Okay, so using interpolation, we have to identify, okay, the FEM. Okay, the FEM for BC and CD. Okay, remember that CD is, okay, CD rotate clockwise, so FEM must be negative for CD. Okay, this must be negative. And beam we have this and this. Okay, this is the angle for beam. Angle is negative, so FEM must be positive. So using interpolation, we can calculate the value. So interpolation, the simple step to do interpolation in order to calculate, okay, FEM. Okay, it is like this. Okay, 0.107 is equivalent to 100. So 0.101 equal to, it is 0.101 divided by 0. This is 101. 107 times 100. So we get 0.101 divided by 0.107 times 100. We get 94.39. This is 94.39. Okay, for CD, it is 0.067 divided by 0.107 times with 100. Times with 100. Okay, so the FEM for CD is 62.62. 62.62. Okay, 62.62. Okay, this is how we identify. This is how we identify FEM due to Sidesway. FEM due to Sidesway. So FEM due to Sidesway will be influenced by the parameters, by 4 parameters. It is E, I, L as well as delta. Okay, and in this case L is not constant, EI is constant, and delta is not constant. So that is why we have to find the ratio. We have to find the relationship. Okay, relationship. Okay, the relationship. This is the relationship. Okay, the relationship, and we have to substitute, okay, into the formula, so that we will get all in EI delta 1 prime. EI delta 1 prime, and then we do simple calculation. It is interpolation to calculate FEM for BC and for CD. Okay, so basically we have to know that, for example, this frame, okay, it deflect like this, it deflect like this, so beam will be like this. So this is the new position of beam. That is why the angle is negative and FEM must be positive. Okay, for CD it is like this, angle is positive, FEM is negative. The same goes to this. Okay, angle is positive, FEM is negative. Okay, that is the most important thing. Okay, we have to assume and to use the right behavior, FEM with the right behavior. So it must be negative, positive, and negative. Okay, so this is whenever a frame is like this. So okay, let's look at the other type of frame. So let's say we have frame like this. Okay, if we have frame like this, let's say this is fixed. Okay, this is due to R prime. Okay, due to R prime. So we have to identify where is the triangular. Okay, because this frame has one inclined column, means there is one triangular in this frame. So perpendicular with AB is this. Perpendicular with CD is this. Okay, join the new position of B prime, B and C. Okay, we have to join this as the new position of B. Okay, the new position of B. So where is the triangular? So it is actually this as delta 1 prime. Okay, vertical is always for beam prime, and horizontal for column CD as vertical element. So this is delta 3. And again, we need to identify the angle. So we find from this. Okay, because it is actually located here. Okay, so we want to find this angle. Okay, so we need to have, okay, original is this. Okay, we need to identify this angle first. Let's say let's say we have this column. Okay, this column. Okay, this is the frame, right? This is the frame. So of course the distance will all be given. Okay, this as well. Okay, for example, this is 3 meter. This is 4 meter, for example. So by using trigonometry, we have to identify this angle. Okay, using trigonometry. So how to determine this? We have to apply trigonometry. So this is 3, this is 4, 3 and 4, 3 and 4. So what is this value? Okay, what is this value? We use tangent. So arc tangent lah. So this is arctangent. So we get theta is equal to, okay, it is arctangent. Okay, it is 4 divided by 3. So the angle is 53.13. So this will be 53.13 minus 90. So we get, okay, this value as 36.87. 36.87. This is 36.87. Okay, so this 36.87 will produce delta 2 prime is equal to sine. This is a sine 36.87 delta 1 prime, and delta 3 prime is cos 36.87 delta 1 prime. So we use this. Okay, we use this to calculate FEM. So let's say we have A, B. We have AB, and then we have B, C. And then we have C, D. AB, BC, and CD. So the first assumption that we made is negative 100 because the frame is tend to sway to right direction. It is negative 100. And then we have to identify the other two values related to negative 100. So of course we need to know that we have to identify whether BC and CD negative or positive. It will be depend on the angle. So by looking at this, the angle for CD, the angle for CD, this is CD, angle is this one. Okay, this AB yang ni angle dia positif. Okay, angle is positive. So when angle is positive, AB is negative. Okay, FEM AB is negative. Okay, then look at BC. Okay, look at BC. BC, the angle is negative. The angle is negative. FEM must be positive. So this must be positive. And then we have to look at to CD. So look at the angle. The angle from original to new position, angle is negative as well. So this is also negative angle. Okay, same to this negative angle. So negative angle produce positive. So we will have two positive FEM in this case. Okay, in this case. So we apply formula. Okay, let's say 5, this is 5 meter. This is 5 meter. Okay, this is 6 meter. This is 3 meter. Okay, 5 meter, 6 meter, and 3 meter. So let's say EI also is not constant. Let's say AB will have 2 EI. Okay, BC EI, CD also EI. Okay, CD also EI. So we have to include all this EI which is not constant into the formula. Okay, so it is 6 times 2 EI. Okay, this is delta 1 prime divided by 5 square. Okay, number 2. Okay, 6 EI delta 2. This is delta 2. So delta 2 is delta 1 prime cos 30. Sine first. Okay, sine 36.87. Okay, divide by 6 square. And then CD, for CD it is 6 EI delta 1 prime cos. Okay, cos 36.87. Okay, divide by 3 square. Okay, we solve this. It is 12 divided by 25. It is 0.48. Okay, EI delta 1 prime. It is in terms of EI delta 1 prime. So here is in terms of EI delta 1 prime. Okay, and then 6 times sine 36.87. Okay, divide by 6 square is 36. So we get 0.1. This is 0.1. Okay, and then 6 times cos 36.87 divide by 9. So it is 0.53. Okay, so we have to do interpolation. Again. Okay, the simple way to do interpolation is by doing like this. It is 0.48, which is equal to 100. So what if it is 0.1? Okay, so it is 0.1 divided by 0.48. Okay, divide by 0.1. It is darab silang times 100. Times 100. So we get 20. So this is 20.83, the FEM. And for 0.53, it is equal to 0.53 divided by 0.48. 0.53 divided by 0.48 times 100. So we get 110.42. 110.42. So this is actually the value. 20.83. This is 20.83. And then 110.42. 110.42. Okay, remember, most important thing, we have to check this because it must reflect behavior. So we will identify from angle, and FEM is opposite with the angle. Okay, angle will be measured from original position to new position. Okay, original position to new position. Then this will be the value that we need to put into the table. So this is for FEM AB, FEM BA. The value is negative 100, negative 100. FEM BC, FEM CB is positive 20.83. FEM CD, FEM DC is 110.442. So this value we will put into the table number 2. Okay, let's say this is table number 2. Okay, let's say this is table number 2. Okay, let's say this is table number 2, and let's say we have used the right K and the right DF. Let's say, okay, so we have to put FEM negative 100 and negative 100. Okay, then the second value is positive 20.83. Positive 20.83. It is positive 20.83. Okay, 20.83. And then FEM for CD, okay, we get positive, right? So it is 110.42. Okay, 110.42. Okay, 110.42. So using this value, so if we have, okay, we have to repeat the same process, the same step. In the table, we have to distribute moment. We have distribute moment by using joint moment. Joint moment is opposite with member and moment. So find joint moment time with the distribution factor, and then we will get the value. Okay, the distribution value. Okay, then the value we will actually carry over, okay, by times with the factor 0.5, because all A, B, C, D fixed. Okay, so all will be divided by 2, or the factor is 0.5, so we get this. So we will get the end moment. Okay, let's say this is the end moment, And then what we need to do after this is, okay, let's say this is M prime. Okay, this is, if this is table number 2, this is M prime. Okay, this is M prime. So we use this value. So we have to continue to use static equilibrium to identify R prime value. Okay, so let's say if this is the value, okay, the value, so the frame is like this. Okay, R prime is this. Okay, so at support we have AY, AX, MA is negative 65.766, negative 65.77. Okay, and at D we have DX, we have DX, okay, DX, and then DY, and then moment is positive. So the moment is 66.71. Okay, so we have to have the shear equation. Total Fx is equal to 0. So relate all horizontal forces, okay, including horizontal reaction. So we have, let's say, 200. Okay, 200 here. No, there's not 200, because it is only due to R prime. 200 for the first table. Okay, for the first table. So this is due to R prime only. So we have to write the equation. So we get AX minus DX plus R prime equal to 0. So now what we want to do is we want to calculate AX and DX so that we can get R prime. So dx will be determined by analyze column CD. Okay, by analyzing column CD, so we, okay, this is dx. Okay, the free body diagram, 66.71 positive. This is 66.71. Okay, and then 22.9, 23. So this is 23. So this is 9 meter, for example. So we can have dx by taking, so let's see, this is C, by taking moment at C. So we will calculate dx. So it is 66.71 plus 23 minus 9 dx. This is equal to 0. Minus 9 dx, it is minus. So dx will be equal to, it is 66.71 plus 23 divided by 9. So we get 9.97. So 9.97 kilonewton. So this is for D. So we have to calculate AX. So to calculate AX, so we have to consider column AB. Column AB is this one, column AB. And for column AB, we have for column AB, we have AY, we have AX. AY and AX. Okay, AY and AX. And then we have moment. Moment at A from the table is negative 65.77. Negative 65.77 and negative 31.53. Negative 31.53. Okay, we have the triangular. So this is 3 meter, this is 4 meter. So by taking moment at B, so we get, taking moment at B. Okay, taking moment at B, we have negative 31.53 minus 65.77. Okay, then minus 4AX, minus 4 4ax minus 4ax Okay, so write the using static equilibrium. Okay, so by taking moment at B, so it is negative 31.53 minus 67. Okay, this, okay, 67.77. Okay, we have negative 4ax and plus 3ay. Plus 3ay. Plus 3ay, this is equal to 0. So we simplify this, we get ax, 4ax minus 3ay, okay, equal to negative 31.53 plus 65.77. We get, okay, here is negative, okay, negative 97.3. So this is actually equation number 1 because we have two unknown. So by solving member AB only, we cannot solve for ax. So what we can do is we have to consider another one. Okay, another one. This is ax. Okay, the moment is 65.77. And the moment, okay, this is the moment is 23, negative 23. So this one is negative 23. So we have, okay, this is 4 meter. So let's say it is 3 plus 3. So let's say this is 6 meter. So we have to, again, taking moment at, now this is C, taking moment at C is equal to 0. So we will have negative 65.77 minus 23 minus 4ax plus 6ay. Okay, this is equal to 0. So we rearrange back. So this is 4ax minus 6ay. Okay, we get 65.77 plus 23. So remain negative. This is 88.77. So this will be equation number 2. So by solving this 1 and 2 using simultaneous equation, so we will get ax and ay. So ax and ay. Okay, then we have also calculated dx previously. So dx is 9.97 kilonewton. Okay, let's say we substitute the value. So we use equation in calculator, two unknown. So we put the value. A1 is 4, negative 3, and then negative 97.3. Okay, and then 4, and then negative 6, and then negative 88.77. So we get negative, this is negative 26.46 kilonewton. And another one is negative 2.84 kilonewton. Then we just need to substitute into this equation, ax. Okay, ax minus dx plus r prime is equal to 0. So we will get ax, okay, prime minus dx prime plus r is equal to 0. So we substitute. Okay, so this is r prime equal to dx prime minus ax prime. So dx we get 9.97. Okay, 9.97 minus ax minus, okay, minus minus 26.46. Okay, so we get this as 9.97 plus 26.46. It is 36.43 and it is positive. Okay, so we do the same actually for previous previous step is non-sway frame. Table 1, we calculate R value. So then once we have this R prime value, we just need to substitute into the formula for M final. Okay, M final. So M naught we get from table number 1. Okay, then we have R divided by R prime as the correction factor. So this is R prime. Okay, and R we get from the previous procedure, previous step. So times with M prime. So we will get 6 value of N moment. Okay, N moment. So we will calculate MAB, MBA, MBC, MCB, MCD, MDC. Okay, 6 value, all 6 value. And then actually we can also get this value by putting in the table like this. Okay, like this. We have AB, we have BA, we have BC, we have CB, we have CD, and DC. Last one is DC. Okay, so we have to put M naught here, and then we have to put M prime here. Okay, and then we can close this table. We can close this table. Okay, this table by M final. So this will be the final answer. This will be the final answer. Okay, the final answer. The final answer. So final. Okay, I'm so sorry. I couldn't make it long for this video because I have to go to kenduri kahwin family. I have to go. So by